Hey everyone, it's Bob Crossan, Senior Managing Editor for Water and Waste Digest. I am here today joined by Jim Georger. He is Western Regional Sales Manager for Veolia Water Technologies. And today we're going to be talking about raw, flashy water, defining the elusive term flashy as it relates to this, and how utilities can address this growing and often unpredictable problem. So, Jim, thank you so much for being here. We really appreciate you taking the time today.
Hello, Bob. How are you?
I'm good. I'm good. Yeah, this is a really elusive term. Could you? So why don't we start with that of flashy raw water, raw flashy water, the order, whatever order you prefer, and like what does this term actually represent and mean?
Sure. It's funny, Bob, when you asked me to do this and we didn't have a topic and you mentioned the word flashy, and I was expecting something a lot more dramatic. But the more I thought about it, it is pretty dramatic because it's not well defined.
Hmm.
So in our business, what you ask, what is flashy? It's different for everybody, but it is a very common term. So it's worth discussing to hear and see what people think when they hear the word flashy. And for this discussion, as we talked about, we'll stick with the topic of drinking water and raw water as it relates to flashy. You'll hear it on the wastewater side when it relates to wet weather events, but for now, let's just stick with raw water and flashy. What is it? I boil it down to it's not the normal raw water condition. And I think there's two components to it. One, there's the extreme of this flashy event or happening, and then duration. So, how extreme does it get, and how long or short does it last defines the flashiness. And I say a non flashy water would be something that's normal, something that the plant sees year in and year out. It may see changes in the raw water quality, but they've seen it before. It's somewhat predictable. That's the norm. Flashy to me is the unknown, the unpredictable, the differences that people are seeing, and then what do we do about it?
Yeah, could you describe a little bit of so one of the things that we had kind of talked about before this call was the TSS and turbidity and like how that might relate to flashy water. Could you describe some of the qualities regarding that and like normal ranges versus extreme ranges? It sounds like that is really helpful in this term where you're talking about it's outside the norm, right?
Right, right. So again, on a more simplistic level, if you will, flashy water to me is changing in turbidity, and in drinking water we call that NTU.
Hmm.
These turbidity units, normal drinking water, conventional drinking water plants can handle very low turbidity, say 1, 2, or 3, up to a normal of 20 or 30, sometimes up to 50, maybe a little bit more. So there's a good range of NTU that a conventional plant can handle. But then you get into the flashy water and the extremes. You have
Hmm.
mountain runoff. You have early season warming that shoots cold water in sooner than later. You have rain events that start washing away, these the silts and the dust. If there are fires throughout the year, it'll pick up those ashes. So that adds to the turbidity or the NTU of the raw water. Now we're seeing numbers above 50 in the range of simply 100 to 200, and in some cases, like in Boulder, Colorado, 1200 NTU. So, there's been real extremes in the Dakotas up to 6,000 NTU. So when you get out of that comfort zone, what is flashy? How flashy is it? And then what do you do about that? So number one is the solids. The turbidity, the NTU is what we're really looking for, number one, but there's other components. There's algae in the water. There's other constituents like pesticides that could wash in. So there could be other flashy events, constituents that need to be considered. But first and foremost, it's particulates and solids.
Why don't we pivot then to some of those events? That was kind of one of the other questions is what events tend to create this? You talked about some runoff things as well, but what are some common events that are often associated with flashy water?
You hear the buzzword climate change, right?
Yeah.
And what does that mean? But we've all seen the goofy weather reports, right? There's storms happening that didn't happen before. There's early winters, late winters, hot summers. So number one, it's the weather patterns.
Hmm.
And what's that doing? In some cases, dropping, like in Houston, 17 inches of water, in a matter of a couple hours. And then you've got the droughts out west where lakes like Folsom and others are completely drying up. So these changes in these reservoirs and these rain flows are really affecting the normal quality of the water. There's other things happening again with the pesticides, the along with the weather. There is the algae blooms. They seem to pop up at different times of the year.
Hmm.
There could be due to temperature changes, turnovers in the lake, where the cold water on top wants to settle, the warm water wants to rise, and that's changing the condition of the raw water. So, and for the most part, it's weather related that's
Hmm.
affecting the raw water.
So when putting this a little bit more into practice, what impact does this then have on, say, a drinking water utility? Like, how does flashy water impact their day to day?
Great question. Again, depending on the flashy water, it may not affect it at all. Most drinking water plants are well designed. They have tolerances. They can adjust when the raw water quality changes, so they can adjust their chemical feed, their flow rates. There are things they can do to get by. As
Hmm.
far as duration goes, that becomes a problem. If a plant has to adjust and do as much as it can, the longer it operates, the more the solids start backing up into the system. The sludge in the settling tanks, the solids load on the filters. Once these things get overloaded, the plant has to shut down.
Hmm.
So, in extreme conditions, and this again happened in Boulder, Colorado, the filters got so overloaded, the water had nowhere to go, had to shut the plant down. So it can be as extreme as taking a plant offline or keeping it online just and add chemical to settle out as much as you can and take the load off the filters. And last but not least is busting permit. You may be able to do what you can to treat the water and get it out to the clear wells and distribution, but if you're not meeting your permit, that could turn into fines and other major problems.
Hmm.
So it's real, it's out there. Can you adjust in most cases? But when it comes to plant expansions or new plants, flashy waters need to be considered.
So when they need to consider it, what are some technologies or services or things that are out there that allow utilities to address this particular issue head on?
There's several things you can do. There's new technologies coming out all the time. You've got to take a step back and look at what's the most cost effective route to get you to the end. What are your current processes at the plant? Can you
Hmm.
supplement those? Or is it a brand new plant and you have to scrap the old and new? So, one, what's the size of the plant and the cost impact for the infrastructure? Two is the operations. There's some very high tech technologies out there. There's membranes, there's RO, there's things that are very costly that you may not need for that flashy event that happens 2 times a year.
Hmm.
So what we look for is not so much the extremes, but the true hard to manage flashy events. What is better than conventional, and what Veolia has to offer is ActiFlow. ActiFlow is ballasted flocculation. It's been around for 25 years. It's a Veolia product. There's probably 1,000 units worldwide, approaching 200 in the United States just for drinking water alone. The beauty of it is it's conventional. I call it on steroids. It's conventional, but it's designed at a rate where we can treat difficult water, but we can also adjust to changing water flows and conditions. And the beauty of the high rate is some people say it's a little too fast to adjust. On the other hand, it gets you feedback rapidly.
Hmm.
So if you've got difficult waters coming in, you make some tweaks to the plant within the active flow in 20 to 30 minutes, you can see the changes you've made and how it affected treatment performance.
Hmm.
We can also look at different chemicals. It's almost like a full scale pilot unit. We can look at different chemicals, different mixing intensities. We can change things up if these flashy waters bring in new constituents. So if we start
Wow.
seeing these microplastics or, you know, uh, uh,
Really, any contaminant of emerging concern, it sounds like.
any contaminant, anything new or different to the plant, we have
Hmm.
ways of experimenting and testing without bringing in, desktop pilot units.
Hmm.
So it's high rate, it's fast performing, and yet it's robust enough to handle these flashes. And last but not least, it's fairly simple to operate. It can be used intermittently. So if the plant is designed properly, you may just need the flashy weather treatment train under those conditions. When it's normally raw water conditions, you can turn that high rate system off and just use it intermittently.
Hmm. So what are you guys getting any feedback on this particular unit of like what more folks will want for it? Like what's kind of next for this particular treatment method? What's next on your radar when it comes to flashy water?
That's a great question because being stagnant or static in your technology development is not a good thing. So we've learned over the years, and some rough numbers, ballasted flocculation started at a rise rate at the back end of 12 to 16 gallon per minute per square foot. Okay.
Hmm.
We're up to 30 to 32 rise rate. So we've constantly advanced the system. We've advanced the mixing system within the maturation tank. We've homed in on the polymers that work better than others. Um, we tell people you don't have to build this thing on the bleeding edge. You can still dial it back to treat the water that you're comfortable with. Last but not least is automation. We
Mm.
can, and the next step is going to be artificial intelligence. So how can we incorporate that into our active flow so that if it starts seeing it drift or it starts seeing trends, it self adjusts?
Hmm.
It's hard to do in the drinking water realm because of the liability to rely on, AI, but it's certainly doable.
Hmm.
So the catch is, do we provide more automation and control or more features to allow the operator to truly operate the plant during flashy conditions and not rely on instrumentation? But
Hmm.
we can offer both.
Yeah. Very interesting that those are kind of like opposite ends of the spectrum, but also solve the same problem, right? Because they're both about this major data and like how do we handle all these specific data points to the best of our abilities and whatnot.
Right,
Very
right.
cool. Very, very cool. Well, thanks so much, Jim. I really appreciate you taking the time and talking to us about this issue. And like I said, it's just such an interesting term. It's very like you said, it's an elusive term, not very well defined, and putting some words behind why we think it is this, it really helps us then solve the problem, right? So, anyway,
It
thank
does.
you. Yeah, thanks again. I appreciate you taking the time. And for everyone who's watching, check out the video description below. We'll have some links to some Veolia resources on flashy water, and we'll also have some stuff on our website about it. So, thanks once more to Jim.
Thank you, Bob. Thanks for having me.